Well, thank you for joining us on this question. We have been given events A and B such that the probability of A is 0.6. The probability of B given A is 0.2, and the probability of A union B, not the probability of A union B, is 0.32. Now, the probability of B given A. Let's just show you illustrations. What is the probability of A? That's A, that's B. The probability of A is this part here. That's the probability of A. If I said what's the probability of, and by the way that's 0.6 in that yellow part, the probability of B given A, well what's that look like in a picture? Well, the probability of B given A means there's A, right? A has happened, right? That means A is the new universal set. So what we do is we ignore everything out around that, because A has happened means A is the new universal set. So A has happened. So if A has happened, how much of that is B? And the part that is B is in here. This is the part that's in B. That's the only part that was in B. And the formula for that is, you might recognize this formula, the probability of A intersect B out of the probability of B. Because it's given A. Out of the probability of A. And that green part is the probability of A intersection B, and that is the yellow part. So it's whatever the green part is divided by the yellow part. That answer is 0.2. That fraction is 0.2. This is just giving you an idea of what the sections we've got. A union B, not A union B. Let me show you what that looks like. There's A, there's B. Now, A is the yellow part, which we said before. B is the green part. And the probability of not A union B is, and I'll highlight this, the red part is not. So that's the part that's around, not inside any of them. It's that part there. Okay, and that red part is 0.32. Okay, so let's see what formulas we've got. We want to find, or we want to prove, the question says prove that A and B are independent. Now we do that by saying if the probability of A is equal to the probability of A given B, then they are independent. What we could do is say if the probability of B is equal to the probability of B given A, then they're independent. And we already know the probability of B given A is 0.2. So does the probability of B equal 0.2? So let's find out what the probability of B is. Well, we know if the red part is 0.32, the probability of A union B not is 0.32, then the probability that A union B is 1 minus the probability that it's not. So 1 minus 0.32 is 0.68. So the yellow and the green part in that diagram is 0.68. Now the yellow part is 0.6. So this is the full yellow part. That means the probability of A union B equals the probability of A plus the probability of B minus the probability of A union B. And we know that this part must be 0.8 because this part is 0.6. The probability of A is 0.6. So the probability of A union B is 0.68. The probability of A is 0.6. We don't know the probability of B. We only know the probability of B that's in there. We don't know the probability of A union B. But what we could do, what are we looking for? We want the probability of B. Okay, so we know that B take away A intersection B is 0.6. Let's go to this equation, 0.2. See what we can find there. The probability of B given A is the probability of A union B over the probability of A. So we know that that's 0.2. We know that A is 0.6, so therefore we can find the probability of A union B. And the probability of A union B is 0.2 times 0.6, which is 1.12. Great. So we now know that this is 0.12 minus 0.12. Therefore, we can find the probability of B. Let's continue that. 0.68, 0.6 plus the probability of B, which we're trying to find out, minus 0.12, which we just worked out. And so that becomes 0.68 minus, take that across to be minus, take that across to be plus, and there's the probability of B. Okay, quick calculation, that's 0.8 plus, that's 0.92. All right, is that right? 0.68, no, that's not correct. Let's put this in the calculator. 0.68, take away 0.6, that is 0.08 plus 0.12, that's 0.2. Yes, the probability of B, does in fact 0.2, and 0.2 does in fact equal 0.2, so this is true, therefore they are independent. So we say therefore, since the probability of B does equal the probability of B given A, because they're both 0.2, then A and set B are independent events. Means that they don't affect each other. If B happens, it still doesn't change the probability of A, and if A happens, it doesn't change the probability of B, because it's still 0.2, even though A happens, it's still 0.2, still 20%. All right, fun, a little bit of a complication. Well, we had to use this part here to work out, we had to use the concept of probability of B given A to find out what the probability of A intersect B is, so that we could then go back and find in this formula what the probability of B equals. Wow, fun. Okay, I hope this has helped. Until next time, stay happy.